Hello viewers, you're welcome once again. We are still under logic. Christ Almighty God's Algebra. In our last tutorial, we treated law of associativity, that is in conjunctive statement. Then we're going to treat also law of associativity in disjunctive statement. Law of associativity in disjunctive statement. Let us start. Law of associativity. Law of associativity. Not P or Q or P is equal to not P or bracket Q or P is equal. Law of associativity. This is an example of law of associativity. Not P or Q or P is equal to not P or bracket Q or P. They are logical equivalent. This equation is logical equivalent because whenever the left hand side of the equation is true, also the right hand side of the equation is also true. Vice versa, whenever the left hand side of the equation is false, also the right hand side of the equation is also false. That means it is logical equivalent. It is not grace because none of them is a subset to each other. Sorry, each of them, they are subset to each other. That means the right hand side of the equation is a subset to the left hand side of the equation. Also, the left hand side of the equation is also the subset of the right hand side of the equation. That means they are equal. Unlike grace, whereby the either left hand side of the equation is a subset of the right hand side of the equation, or the right hand side of the equation is a subset of the left hand side of the equation. We say that it is grace, but it's not in this case. They are equal to each other. That's why it is law. And this law is in disjunctive statement. We have treated the law in conjunctive statement. Today is in disjunctive statement. We are going to prove that this side is equal to this side and this side is equal to this side. Let's start. So prove suppose bracket not P or Q or P is equal to not P or bracket Q or P. We assume that this statement it is true. That means it's our hypothesis that not P or Q in bracket or P is equal to not P or bracket Q or P. They are equal. If that is the case, since whenever the left hand side of the equation is true, also the right hand side of the equation is also true. Whenever the right hand side of the equation is false, also the left hand side of the equation is also false. If that is the case, we say that if and only if bracket not P or Q or P, if and only if not P or bracket Q or P is tautology being justified by logical equivalence. Being justified by logical equivalent. We have now transformed this equation to biconditional statement. This equation has been transformed to biconditional statement. Reason is that whenever the value of the right hand side of the equation is false, also the value of the right hand side is also false. Whenever the value of the right hand side of the equation is truth, also the value of the left hand side of the equation is also truth. So in this case, we brought it to biconditional statement, that is equivalent to tautology. That means when we evaluate these two sides of the equation, it will give us what we call tautology. That means always truth. In any evaluation, it will give us truth. There's no possibility of getting falsity in this statement. Always truth. Because whenever the right equivalent is false, also the left equivalent is also false. Whenever the left equivalent is truth, also the right equivalent is also truth. If that is the case, we say that it is tautology, being justified by logical equivalent. So if and only if bracket not P or Q bracket or P implies not P or bracket Q or P is tautology being justified by logical implication. We have seen that we have now transformed the biconditional statement to conditional statement. Due to that, whenever this equivalent is truth, also this equivalent must also be truth. If that is the case, we say that not P or Q or P implies not P or bracket Q or P is also tautology. It maintains tautology. That means whenever the antecedent is truth, also the consequence must also be truth. If that is the case, there's no way we obtain falsity in this statement when we evaluate it. In the version of this statement, we can never obtain falsity, always truth. That means there's no possibility of getting falsity. If that is the case, he said that is tautology, being justified by logical implication. Since statement is tautology, it means that the antecedent is the logical implication of the consequence, and also the consequence is a logical consequence of the antecedent. I mean, this antecedent, this not P or Q in brackets or P. So that it is certain that they exist. The implication exists, and also the consequence is also exists. That means the antecedent exists, and also the consequence is also exists. We then say if and only if bracket not P or Q or P is logical implication of not P or bracket Q or P. That is not P, the antecedent is logical implication of the consequent. That means the antecedent is not P or Q or P. Is logical implication of the consequent, not P or bracket Q or P. If that is true, also, you say that if and only if not bracket, not P or Q or P is equal to bracket, not P or Q or P, being justified by identity. By identity. It's being justified by identity. That means if not P or Q or P is logical implication of not P or bracket Q or P, it's also true that not P or Q or in bracket or P is equal to not P or Q in bracket or P. That means it's equal to itself and it is law. It is logical equivalent. It is law. That is that the logical implication is equal to itself. So being justified by identity, that is the same next. If and only if not P or Q in all brackets is equal to bracket not P or Q or P bracket the not P or Q that is in conjunctive statement has now been transformed to conditional statement. This is not Q. That means not P or Q that is in disjunctive statement has now been transformed to conditional statement. That means that not P or Q is equal to, is logical equivalent of not P, not Q implies not P. That means not P upon not Q. Or you bring down the P or P. Being justified by being justified by being justified by first educators law. Being justified by first educators law, that is to say that not P or Q is equal to not Q implies not P. So it's being justified by first educators law because it is equivalent to the not P or Q is equivalent, it's logical equivalent to not Q implies not P. That means not P upon not Q. So by educators law, it's being justified by first educators law. Say if and only if, because it still maintain the is still equal to the left hand side of the equation, and is still law. It never changed to grade, it still maintain law. So because here is tautology, here is also tautology because not Q implies not P is equal to or P is equal to tautology. Say if and only if bracket not P or Q or P is equal to, we then distribute not Q to this disjoint P. Distribute not Q to disjoint P. We have not P or P upon not Q. It still maintain tautology. It still maintain tautology because not P or P upon not Q is equal to tautology, as the left hand side is equal to tautology in value. Also, the right hand side is also equal to tautology in value. So, by being justified by distribution of implication, being justified by distribution of implication, because this implication, not Q, is related to the disjoint P. It becomes P upon not Q, being justified by distribution of implication. We have done distribution of implication. So we can visit our previous tutorial in distribution of implication. We continue to this side. Say, if and only if bracket not P or Q or P is equal to this not P, you write it down, or you write or, then convert this statement not Q implies P. That means P upon not Q, you convert it to disjunctive statement, because this implication not Q is being generated from the disjunctive statement. Is being generated from disjunctive statement. That is to say, not P or Q. It is disjunctive statement. So when you want to convert it back, it will be also in disjunctive statement. So here we are going to convert it to its equivalent to disjunctive statement. It will be bracket Q or P. You still maintain equivalent. You still maintain logical equivalent. Being justified by first educators law, because this equivalent of P upon not Q to its equivalent to Joseph statement, it is Q or P by educators law. You see that they have now proved the statement, that means not P or Q, or the bracket or P is equal to not P or bracket Q or P. They have proved it. That you say thus bracket not P or Q or P is equal to not P or bracket Q or P. It is law. They are logical equivalent. They are subject to each other. So we are going to prove the converse. Since they are subject to each other, we are going to prove the converse. You say conversely, 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 not P or bracket Q or P is equal to bracket not P or Q or P. You want to put the converse. Say suppose not P or bracket Q or P is equal to bracket not P or Q or P. That means we assume that this statement is truth. That means not P or bracket Q or P is equal to bracket not P or Q or P. That is the converse. Since we assume that it is true, it's our hypothesis. We say that if and only if not P or bracket Q or P, if and only if bracket not P or Q or P is tautology being justified by logical equivalence. Now the statement not P or bracket Q or P equal to bracket not P or Q or P, we have now converted it to birational statement. Since whenever the left answer of the question is truth, also the right answer of the question is also truth. Vice versa, whenever the right answer of the equation is false, also the left answer of the equation is also false. If that's the case, we then convert it to birational statement and it is tautology. The valuation will give us tautology because there is no way we can obtain falsity. That means there's no possibility of falsity in this statement valuation. It's always together I say that it is tautology being justified by logical equivalence. We continue to this side. Say if and only if not P or bracket Q or P implies bracket not P or Q bracket or P. Is tautology being justified by logical implication. The statement, the birational statement has now been transformed to conditional statement due to that whenever this equivalent is truth, also this equivalent must also be truth. That means whenever the left side of the equivalent is truth, also the right side of the equivalent must also be truth. If that is the case, we say that the not P or bracket Q or P implies bracket not P or Q or P still maintain, it still preserves tautology. It still preserves tautology. That means it is tautology being justified by logical implication. Since this is truth, we say that if and only if not P or bracket Q or P is logical implication of not P or Q or P. So it's logical implication of not P or Q or the bracket or P. That means it is certain that not P or bracket Q or P exists. It exists. So because of the statement is tautology, there's no possibility of ascertaining falsity in the statement. So it is certain that not P or bracket Q or P exists. And if certain that it exists, it says that it is logical implication of the consequent. That means not P or Q, or in bracket or P. If this is true, also this is also true. You say if and only if not P or bracket Q or P is equal to not P or bracket Q or P, being justified by identity. Now you will see that the logical implication is now equal to itself. It is truth that it is equal to itself, being justified by identity is logical equivalent because whenever the implication, the logical implication is truth, also logical implication is also truth. So by saying this, they are equal, they are equal. That means it is equal to itself by, and it is law. Logical equivalent. So just by identity, sameness. Say if and only if not P or bracket Q or P is equal to not P or P upon not Q. You have seen that you have now transformed not Q or P to conditional statement. Its logical equivalent to conditional statement. That means Q or P is logical equivalent to not Q implies P. That is P upon not Q. So being justified by first Ejike's law is through Ejike's law that we transform it to its logical equivalent in conditional statement. So by first Ejike's law, that to say Q or P is equal to not Q implies P. We continue to this side. Say if and only if not P or bracket Q or P is equal to, let's distribute this implication to this disjunct, that not P, disjunct. You're going to have not P upon not Q or P. Still maintain equivalent, still tautology. Here is tautology, here is also tautology, is tautology. So still maintain equivalent, still maintain logical equivalent. So we have not P upon not Q or P. Still maintain tautology. Justify by, being justified by distribution of implication. That means this implication that is here and that is equal to this disjunct. So if and only if not P or bracket Q or P is equal to, now this not Q is being generated through disjunctive statement. So if you want to convert it, if you want to find it, this statement is equivalent, it's going to also be to disjunctive statement. So we are going to have not P or Q or P being justified by first Etiquette's law. That is to say that not P or Q is equal to not Q implies not P. So is logical equivalent not P upon not Q is logical equivalent of not P or Q being justified by first Etiquette's law. That is not P or Q is equal to not P implies not P. We have now proved the converse. We have now proved the converse. That means not P or bracket Q or P is equal to not P or Q or P. We have now proved the converse. That means by law of extensionality, they are the statement is true. That means not P or Q or P is equal to not P or bracket Q or P. He said thus not P or bracket Q or P is equal to bracket not P or Q or P. We then conclude say therefore not P or Q all in bracket or P is equal to not P or bracket Q or P. So we have now proved that the law of associativity exists in disjunctive statement. We have now proved it that law of associativity exists in disjunctive statements as it exists in conjunctive statement. It also exists in disjunctive statement. So we have now proved the converse to show that it is law. So at this juncture, I withdraw our curtain. Thank you, viewers.